In today's lesson, we're going to be talking about relations and functions. So starting off here, we want to take a look at what is the actual definition of a relation. Well, a relation is any set of ordered pairs. So ordered pairs can be viewed in set notation, and when viewing a relation in set notation, how we would read this would be read as 1 is related to 2, 0 is related to 5, and 1 is related to a half. Notice here this relation only has 3 inputs, 1, 0, and 1 again, and it has 3 outputs, 2, 5, and a half. This relation has order 3. Some relations can be finite in size and others can be infinite. Let's take a look at a relation that is not expressed in set notation. So moving on, we can also express relations graphically. You'll notice here along this line, this linear relation, we have an infinite number of points. I've highlighted some of the points here to discuss, but like I was saying, there's an infinite number of points on this relation here, unlike the previous example, which only consisted of 3 relations. We have an infinite number of relations in this set here, and in this case here, you could say that 2 is related to 4, negative 2 is related to 0, and negative 4 is related to negative 2. So relations can also be expressed graphically in this manner. Let's take a look at another example. In this example here, again, we have a graphical relation. This is the unit circle, so this is x squared plus y squared is 1. You'll notice here along this relation here, we have an infinite number of points, just like in the previous example. And, we could say 1 is related to 0, 0 is related to 1, negative 1 is related to 0, and 0 is related to negative 1. So this is a relation as well. Now that we looked at several examples of relations, we want to talk about what exactly is a function. It turns out that every function is a relation, but not every relation is a function. So in the 3 examples we've just gone through, some of these examples are in fact functions as well, and some of these are not. So let's take a look at what the definition of a function is. What a function is a function is a relation, so it has to be a relation first to even consider it being a function. So a function is a relation such that for every value of x, there exists a unique y, and this term unique is important. There's a unique y such that f at x equals y. So essentially what that means is that for every input that you have in your relation, let's say we have an input of 1, it cannot be the situation that that 1 is related to, let's say, 2 and 4. Because then what that would mean is that you have a not unique y value, a non-unique output. Right? You can have a relation such that it goes from, let's say 1 and 2 are both sent to a value 4. That is fine because each input has a unique output. It's not being sent to 2 different values. So in this quick little example I've drawn up here, if I write this in set notation, this relation would be written as the relation 1, 2 and the relation 1, 4. And this relation here, let's call this A as well. It will be the relation 1, 4, and then the relation 2, 4. So as a quick example here, if you take a look, you'll notice that this relation is not a function, and this relation is a function, right? And the reason for that is, again, this input has 2 different outputs. So it is a relation, but it is not a function. Each input here has a unique output value. Unique in that 1 is being sent to 4, 2 is being sent to 4. However, 1 is only going to one location, in this case 4. 2 is only being sent to one location, a unique location, which is also 4. All right, let's take a look at the previous 3 examples and see which of these relations are in fact functions. So coming back to the work we did prior, notice here we have 1 is related to 2, and 1 is related to a half. Therefore, this is not a function. So you'll notice here again, we do not have a unique output. Let's take a look at our linear relation. So this linear relation you would have seen in grade 9 or so. Turns out it is a function, and you notice that it is a function because for every value of x, it outputs a unique y value. For every input here, negative 2, it outputs a unique y value. For every input, it outputs a unique y value. So this relation is in fact a function as well. All right, let's take a look at our unit circle here. You will notice here with the unit circle, notice that in this example here, we have 0 is related to negative 1, and 0 is also related to 1. So right away, this relation is not a function. When determining whether a relation which is expressed graphically is a function or not, there's a useful technique called the vertical line test that we can use to discover whether a relation is a function when it's expressed graphically. Let's take a look at the vertical line test. So using the vertical line test here, you can see that we have some relations here. I have the relation, it's a quadratic, and then we have another relation here that we talked about as well. With the vertical line test, what you want to do is you want to create yourself a vertical line and move that vertical line along the relation. And if the vertical line crosses the relation twice in any singular spot, then it is not a function. So for instance, as we take a look here, you'll notice as this vertical line goes across the x-axis, as I move it across the x-axis, for every x value there is a unique y. It doesn't cross twice, and it would be a function. The same is not true for the following relation. As I move this vertical line across the relation, you can see here that it is for any fixed value of x I choose. Let's say we fix it here. You can see that it is crossing twice. And because of that, what you're going to get is you're going to be in a situation where, let's say, you might have -2 is related to 4, and then somewhere over here, once again, you'll have -2 is related to -4. So for a given input, you have two different outputs, and by creating this vertical line test, you can quickly find those spots where the definition of a function would fail for a relation. So just to summarize what we've been talking about, every single function, if you have an expression that is a function, it is automatically a relation, because the set of all functions are contained inside of a larger set, and that is the set of all relations. So again, every function is a relation, but not every relation is a function. Let's take a look at some examples. Okay, let's take a look at the following relations here and decide which ones of these are functions. You notice here -3 is being sent to 3, 3 is being sent to 3. We're looking for a situation where a given input has two different outputs. You'll notice we don't have that here. 0 is going just to one value. 1 is going to just one value. -1 is going to just one location. And the same can be said about 2, -2, 3, and -3. So in fact, number 1 is a function. All right, let's take a look at number 2 here. You'll notice 1 is being sent to 2, 2 is being sent to 3, 3 is being sent to 4, and 4 is being sent to 1. So again, once again, this would fall under the category of a function. Let's take a look at number 3 here. For number 3, we can see that P is being sent to R. Now here we got Q is being sent to R, and Q is being sent to W, and Q is being sent to T. So we have, for a fixed input, we have 3 different outputs, and in which case here, this is not a function. For number 4 here, you would have seen this graph in your previous courses here. You know this is the absolute value of x. If I were to graph that, that's going to look something like this. Graphing the absolute value of x, you notice right away you can see that this is going to pass the vertical line test, right? If I want to go ahead and do the vertical line test here, you can see that as I move this along here for a fixed x, there's a unique y. It's not crossing twice. And because of that, this is in fact a function. Taking a look at number 5 here. Number 5, if you were to graph number 5, it's going to look like this. And once again, doing the vertical line test here, you can see that as I take this vertical line and pass it through the function for a given x, there's 2 different outputs, as it is crossing twice, and then therefore because of that, this is not a function. Now notice if they would have omitted the plus or minus, so because of the plus or minus, you have the top half of the circle and the bottom half of the circle. If I would take this exact same question, let's say we deleted the minus sign, we just had a plus. If we had done that, then your circle would not look like this. Your circle would only have the top half colored in, so the circle would look something like this, and in which case that would in fact be a function. And likewise, if we were to delete the plus and put a minus there and go below, you would see that in fact the bottom half is a function, as the top half would be gone now. But with the plus or minus there present, this is not a function. It is a relation, but is not a function. For number 6 here, if we go to graph number 6, graphically number 6 would look like the following. So graphically, this would be what number 6 would look like. And if you take a look at number 6 here, again, doing the vertical line test, you can see it fails the vertical line test. For a given x, there are a situation where you have 2 different outputs, and this is not a function in x. And I use the term not a function in x because it actually is a function in y, because if you apply the horizontal line test, and this would be testing whether you have a function in y, you see it actually doesn't cross twice. But the focus for grade 12 and even first year university is this a function at x? We're looking at functions in your x-axis. So in this case here, for a given x, there's two different outputs, and therefore we have not a function. For the final example here, we have a scatter plot, and we can use this to determine whether this is a function or not. Now notice here, for every x, there's a unique y. For every x, there's a unique y. Every x, a unique y. And every x, a unique y. So this passes the vertical line test, in which case you would say this is a function. Now suppose I took this exact same scatter plot that we have and I added another point. Let's say we added a point right here. You'll see now this will fail the vertical line test, as for a given x you have two different y values, two different outputs for a given x, and therefore it is not a function. But in its current form, illustrated here, this relation is also a function. All right, that concludes today's lesson on relations and functions.